All right. Welcome to another video sessions. Okay, so in this video, we are going to discuss the Dijkstra's algorithm. Um, Thus far, we talked about two different search algorithm. One was the breadth first search algorithm, and the other one was the depth first search algorithm. I'm going to have another video for you to go through that BFS and DFS in a little more detail if you're not sure about what we did on the other day. Uh, I will give you maybe one or two other examples so you guys can go through. It's not really uh, you know uh, complicated search compared to the Dijkstra's. But nevertheless, I want you to have a good understanding on, breadth first search and depth first search. That would be very important later on. So when we looked at the breadth first or depth first search, the ideal behind those search algorithm is the what would be the minimum segments that are that I need to take from going from one, uh, from like starting node to the ending node. So rather than, the distance, meaning the fastest, this was more of the shortest, path to the place that we want to go. So for example, if you look at the diagram on the left over here, I have path from A to B to C. Then I have another one A to D to E to C. So both paths are going to lead into the node C. But the BFS and DFS is, we are concerned about the number of segments that we are going to take in order to get there. So if you look at the blue path on the top here, we only have two segments, right? So go from A to B and B to C. So that's just going to be two segments. If you take the bottom one, the purple path, it will take you three segments, right? Because A to D, D to E, and E to C. So when we're talking about the BFS and DFS, we are concerning what is the minimum number of segments that I can take in order to get to the place I want to go. So obviously, if you're talking about the number of segments, then you're going to take the blue path because it only has two segments compared to the three segments at the bottom with the purple path. So that's the basic idea of breadth first and the depth first. Now, although we are using different data structures, breadth first we are using queue, and the depth first we are using stack. The idea behind these two search algorithm is, can I get to the minimum segments from point A to point C? So that's the whole idea based on the BFS and DFS, right? Minimum number of segments. Now, but what if we assign the distance, the time, let's say? Okay, so for example, on the same path, the blue path, going from A to B takes about 15 minutes, and then from B to C, it takes about 60 minutes. So from going from A to C, if you take the blue path, it will give you 110 minutes. Now, on the other hand, if you take the purple path over here, let's say A to D is 20 minutes, D to E is also 20 minutes, and E to C is 60 minutes. But even though we have more number of segments, the time it takes go through from starting A to the ending C is only 100 minutes. So that means we have the fastest, right? So in other words, that if you take the path, blue path, it will take you 110 minutes. If you take the purple path, it will give you 100 minutes. So the bottom one, okay, the bottom path, the purple path, is going to be faster than the blue path up there. So this is the what we call weighted graph, right? Because now edges now have values, the weight between these nodes, and the we want to, rather than number of segments, we want to find out how long it's gonna for us to take it to get there from point A to point C. When we study this, it kind of reminds me about the mileage program in the airline. So, for example, Delta Airlines, in order to be like medallion status, like silver, and then they have gold and platinum, whatever. They have the requirements. So they have so much money you have to spend, and then you're gonna have to accumulate so many miles, or you're gonna have to accumulate so many segments. Okay. So we're going to find out. Yeah, the airline mileage is kind of things kind of I pop up to me when I look at these problems. Always comes up to my mind saying, "Oh yeah, mileage and the segments, right?" So we want to know, if the graphs are weighted, what would be the systematic way to find the fastest path from point A to, in this case, point C. So the one way we can do that is what we call Dijkstra's algorithm. So this is going to give us the systematic way to find the fastest path from the graph. Okay, so let's just go through this on one more time here. So in last lecture, we figured out a way to get from point A to point B. So in this example that we went through, we went from Twin Peaks to the Golden Gate Bridge, and we found out that there are 3 segments on the top path that will take us to the Golden Gate Bridge, compared to the other path, which will take 4, right? So when we look at this graph, that will be the shortest path to the Golden Gate Bridge. But as I mentioned, it's not necessarily the fastest. Okay, so now we're going to assign time to these paths, the edges. Okay, so from like Twin Peaks to the first bus stop is going to be 4 minutes. Then after the first bus stop, then the next bus stop is going to be 21 minutes, and so on. Okay. So we used the breadth first search in the last lecture, and the breadth first search will find you the path with the fewest segments. That's what we just talked about. And now we want to find out if you add the weight, in this case, a time, to the segments, what would be the fastest path from Twin Peaks to the Golden Gate Bridge, right? So Dijkstra's algorithm is the systematic way of finding the fastest path with when the graph has the weight on it. It can be a time, it could be anything, just the units. Okay. So I'm just gonna giving you some idea here. So now we are not really concerned about number of segments, as long as the time, in this case, or units, whatever you want to call it, as long as the total weight is going to be smaller, then that's what we want to take. It could be maybe 10 segments compared to 5 segments. It doesn't really matter about the number of segments, but we only care about what would be the total weight at the end. That's going to be the so this is going to be, like a good problem for like the companies that are delivering stuff like Amazon.com, UPS, FedEx, those kind of people, right? Because if you can take the short fastest route, then it's going to be better, right? Because um, it's going to save you money. So for example, if you look at the diagram on the left, I have from the starting point to finish, I have one path on the top is a 6 + 1, 7 minutes to get there. But if I take the another route, even though it has to go 3 different segments, it's going to give me a less time. So 3 + 2 + 1, you get 6 rather than 7. Okay, so that's going to be the whole idea. Now I have written some steps to find the using Dijkstra's algorithm to find the fastest path. But I'm going to show you the other way, which will be much easier if you are the visual learner. Or I'm just going to go through the one by one step at a time. So, I mean, you can do this. Yeah, I mean, that's nothing wrong with what I just wrote up here. But I found out that students like this way better, so we're going to do this way. Okay, so I want you to look at the the table, not the table, but the graph on the left. Okay, so we're going to start from A, and each path from between the nodes has weight. So these red numbers are the weight. It doesn't matter whether it's going to be a time, distance. It's not really matter, but it is a unit between nodes here. So in other words, that from A to C, it takes 5 units. Okay, and like A to B, it takes 3 units, and so on. So what we want to do here is that we want to apply the Dijkstra's algorithm and to find the shortest, not the shortest, but fastest path from this, graph, and we're going to do it as a table here. Okay, so we're going to start from A. Okay, so from A to A, there's no distance or nothing. So what I'm going to do is I'm going to put 0. Okay, over here. Oh, not that. So we're going to put 0 here. Okay, and we're also going to write subscript indicating that where this thing is coming from. So this is A, so I'm just going to put A over here. Okay, so now I'm going to put the box around here, meaning that this is completed. Okay, so that, I mean 0, A is A, it's not going anywhere. So we finished that. And we are going to, starting at A, so I'm going to put A over here. And all these letters over here on the top row is the different vertices of this graph here. And we are going to calculate the, units from A to these vertices here. So from A, this V over here is indicating which vertex we are working on. Okay, so this is going to, let me just put that here. And this is going to be a vertex we are working on. Okay, so vertex we are working on. Okay, so now I am at A. So A to A is obviously going to be 0, right? So I said, so we're going to put A there because it's the vertex A. Now between A and B, so I'm going to go to A to B. Now that's the 3 units. So I'm going to put 3. And I'm going to put subscript A, indicating that this is A is the vertex that it came from. Okay, so A to B is a 3 units. Oh, that's fine. Okay, so far so good. Now we're going to go to A to C. Okay, so now it indicates the 5 units. So I'm going to put 5, and at the same time, I am going to indicate that this comes from A. And we're going to repeat the same process here. Now let's go from A to D. And that's going to be 6 units, right? Again, this thing came from A. I'm going to put A there. Now from A to E, you cannot get there because, we don't have any direct path from A to E. So we're just going to put the infinity sign here. That's unreachable. And same thing for the A and F, right? So it's unreachable. So we're going to put the infinity sign, and same thing for the G. Okay. All right. So now what we're going to do is next is we are going to look at the units over here. Okay, I want you to look at all the units over here that we just came up with. Okay. Then I want you to select the shortest, smallest unit. Okay, and that's the next vertex that we're going to work on. Okay, so when you look at the smallest, except this box here, box means it's already done, so we don't have to worry about that one. And the 3 is going to be the smallest. Okay, 3 is less than 5 and less than 6, obviously less than infinity, right? So what we're going to do here is that we are going to bring that down, 3A down here. And then we're going to put the box then, which means that this is going to be done. Okay. But okay, let me just put it nicely. Okay, so we have, okay, but 3A is come from the B vertex, right? So we are working on now is going to be B vertex. Now A, we don't have to worry about it because it's already done, okay, because box is in there. So B, this is what we are working on right now. Now the next thing that we're going to be working on is going to be C. I'm going to make this box a little bit smaller here so you guys can see. Okay, so I'm going to make it like that. All right. Okay, pardon me. All right. So then we go to between B and C, right? So when you look at the B and C, in order to reach that, okay, there is no direct path. So you cannot go there directly. So we're just going to have to bring it down at 5A, which will be the smallest. Okay, so we're just going to get 5A. Now, next one's going to be a BD. Now, BD here is going to be 2 units. But B has to come from A though, right? Because it's going to be the total path is going to be A, B, and D. So B and D is going to be 2. But prior to that, A and B was a 3. So 3 plus 2 is going to be 5. And I want you to compare that to the one we have right now. In this case, a 6. Right? So we are comparing this. Right now is indicating that it takes about 6 units to get from A to D. But if I go through B, it will take 5. Okay? So we're gonna it's gonna be smaller than 6. So we're gonna use that 5 there. Now remember that the vertex that it comes from is going to be B. So we're going to have to put 5 here. Then we're going to have to put B. So what we're saying here is that rather than taking the direct path from A to D, which was a 6 unit right above here, if we take from A to B and B to D, that's what this means, right? Because A to B is a 3 units, and then from B to D is 2 units. So 3 plus 2, you get 5, which is smaller than 6, and that's what we're going to take. All right. Now, next one's going to be B to E, okay? But we cannot get there. It's unreachable. So we are going to put infinity, same thing for the B to F, and same thing for the B to G. Okay, so we are done with the vertex B. So we finished. Now, next we are going to look at, okay, this row here, and we're going to find out which one has the smallest weight or smallest unit over here. So I'm just going to, since we have two 5s over here, so I'm just going to go with the 5A. Okay. So that means that now we are going to work on the vertex C. So I'm just going to bring this thing down here. So I'm just going to indicate that this came down here and that this is going to come down here. Okay. So we're going to put 5A here. Then we're going to put the box here. Then, this vertex is going to finish. Okay, now we're going to work on the vertex C now. Okay, so C. So A is done, B is done, and the C is done, right? So now we're going to have to work on the remaining path. Oh, wait. I made this thing too big. So I need to get this thing, okay. So we need to work on the D now. C, between C and D. Let's take a look. C and D is going to be 2 units, okay. But if you look at the any other options over here, okay, the originally that we have a 5 is coming from B though, right? Okay, get to the D, we decide to take A, B, and B, D, and we ended up with a 5, but previously it was a 6. Now we want to have a C. So in other words, that we want to go from D to B, I mean A to B, B to D, and D to C. But that's going to be a 7 units. But that's going to be greater than 5. So we don't want that. Okay, so we're going to keep the 5B here. Okay, I think it's black here. Okay, so let's just make sure. If I go through the C to D, that's going to be over here. C to D. That means that we're going to have to go to D to B, okay, A to B, B to A, and A to C, and then back to C to D. But that's going to take a lot more than 5B, right? So that's going to be 12, right? Because that's what we're going here. Because right now, the 5B is going to be, in order to get to the D, we took A to B and B to D. It only takes 5 units. Now, compare that to if I want to go to the C to D, the C to D, then you're going to have to come to A to C, and C to D, that takes 7 units, not 11, but 7 units, right? 5 and 2. And it takes 7 units, but mine is going to be better here. We already figured that out. Okay. To get to the D, if I take A to B and B to D, it takes about 5 units, not 7. So 5 is going to be smaller than 7 units. So we're going to keep the 5 path. Now, next one's going to be a C to E. Now, that's going to be a 11, 6 and 5, right? Because we are coming from 5, then we go A to C, then we're going to go C to E. So that's going to be 11. It's going to be less than infinity, right? So we're going to write 11C. What about C and F? Okay, so currently we have unreachable infinity, right? So if I look at the C right now, C to F, I can get there from A to C, which is a 5, and C to F, 3 units. So that's going to be a total of 8. Okay. So I'm going to write 8. It comes from C, vertex C. Okay. Now, next one is going to be C and G, right? So C and G is going to be 7 units and the 5 units between A and C. So that's going to be a total of 12 units. Better than infinity, right? So we're going to write 12 and C. Okay. So we're doing all right. So now next one is going to be the, look at the rows again. Let me just put this thing over here. So now I'm going to color a different one here. So let's look at this guy. So we're going to look at the remainder here. Okay, all right. So the smallest value here among these 4, the vertex is going to be 5b. So I am going to bring that down. Okay, here's a 5b. So I'm going to, this is coming from that 5b there. And yeah, we're going to put the box around. Oh, I did it again. Okay. So we're going to put box around it. Okay. Then this is going to be a vertex D. So we're going to work on the vertex D here. Okay. All right, so everything else has been done so far. A is done, B is done, C is done, and D is done. The vertex in terms of a vertex, right? So now we're going to look at between the vertex D and E. Okay, so if you look at the D and E over there, we have 11. All right. If I go from, right now is going to be C, going from A to C and C to E. Now, if I go from the D to E now, okay, that's going to be you coming from A to D, D to C, and C to E. So that's going to be like what? 14? So 14 is greater than 11. So we don't want to take that one. So we're just going to keep the 11. So we're going to have 11. Okay, C over here. Okay. Now what about and D and F? Now that's going to be the 9. So between the 9 and F, D and F. So if you go coming from A to D and D to F, that's going to be 15. It's going to be greater than 8. So we don't want that. We just want to keep the 8. Remember that the 8C is coming from, right? In this case, C and F. Okay, so what we just did here is that we did compare that A to C and C to F. That was the 8 units. Now D to F, we compare that to A to D and D to F. So that's 15. So coming from A to C and C to F is going to be much smaller than compared to the coming from A to D and D to F. Okay. Now let's look at the next one, D and G. We cannot reach that, okay, from D to G. Okay, so that's going to be infinity, but we had that 12C before, so we're going to use that. So that's going to be 12C. Okay, all right, so now I'm going to color this again. I'm just going to use the light color here. Okay, so now we have these three. Okay. So the smallest one is going to be 8C. So we're going to bring that down. Okay, 8C now. And let's put the box around it. Okay, and so this is going to be F. Okay. So as you can see that A is done, B is done. Oh, sorry. And the C is done, D is done. Okay, we haven't got to the E and G yet. So, but we are working on F. So here the F and E. So that's going to be the 5 units. Okay, so let's take a look. If you want to go from F and E, okay, there was a couple of paths over here. Now, as long as, you know, whatever the path you're going to come up with is going to be less than 11, we're going to take it. If not, then, you know, we can't. So the way that we can come up to the E will be, you got 3 here, 2 here, 9 there, 5 there. That's obviously greater than 11. So we're not going to take that. Or you can take from A to D and D to C and the C to F and then F to E. So that's going to be what? 16? I don't think so. Okay. So whatever that, you know, you want to, you know, go map the path, you know, you're just going to go from A to, you know, go through the, go to E, but you have to go through F and compare that to the going from A to C and C to E, because that's what the 11C is, and that's what this 11C that you're looking at over here. And you are comparing that to all the other possible paths that ends up in the F, so we can go from F to E. But we don't have any. The 5 and 6 is going to be the fastest. So we're just going to, we don't have any, we try a few of them, you know, it's always greater than 11. So we are going to bring down the 11C. Okay, so we're going to bring the 11C. Now we're going to look at the F and G now. We had 12 before, right? So if you look at the 12, right, we came up with the, you know, this direction here, 2, 9, and the 1, right? Because the we could not go directly from D to G here, but previously we had, you know, if you look at this table carefully, from C to G was 7, and then the C to A was 5. So 7 plus 5 was 12, and that's what we had at before at the C, right? And the D, we were not able to, you know, directly go to G, so it was unreachable. We just had, you know, it's infinity, so 12C is much better than infinity, so that's why we put the 12C there. So that's how we got from A to G there, you know, going through the C. So we need to find out, see if there's any other path that you can go through F, and less than 12. So if you look at this one over here, you can have, okay, uh, the go through the what is this? Let's find out what we have here. Okay, so from F and G is 1 unit. Okay, and the we need to find out. See, oh yeah. So if you look at the path is going to be from between F and G is going to be 1. But if you're coming from A to C, that's going to be a 5. And if you're coming from C to F, it's going to be 3. Okay. And that's what I will show you in a minute. Okay. So instead of going through the directly from A to C and C to G, we can go from A to C, then go to F, which is 3 units. Then go from F to G is another 1 unit. So that's going to be a total of 9 units. Instead of a 12, 9 is much smaller than 12. So we're going to use that. So then you're going to have a 9. It's coming from F. Okay. All right. So we're almost done here. So now I'm going to shade. Okay. Couple of them here. So now we are left over with the 11C here. Then we got 9F over here. So obviously the 9F is smaller than 11, so 9 is. So we're going to use the 9F. We're going to bring that down over here like this. Okay, now I'm going to bring that down 9F. Okay, and we're going to box around it. And then that's the vertex that we need to work on. So that's the vertex G. Okay. The only thing that we have now is going from vertex G to E. All right. So if you look at the from F to E, so if you look at the way that we got 11C was, if you look at it from F to E, I mean not F to E, but to the D and E. Okay, so let me see. So we are looking at this one over here, 11C. So we're going to go from G to E over here. Okay, but we need to compare that to 11C coming from A. So right now, if you go directly from 5 to going directly from A to C and C to E, that's the 11. So that's what the 11C is coming from here and going to the E. Now, is there any other path, okay, going through G though, that can give us the smaller than 11 units? We can try something like 3 to the A, B, D, F, G, then go to E. So, but that's going to be a lot more than 11. We can try like A, D, C, F, G, E. So, but that's going to take about 15 units. So that doesn't make any sense. The other path we can take is going to be A to C, then C go to the F, that's 8. Okay, then F goes to G, which is a 9. Then 9, G goes to 11, but the same thing, right? Oops. 11 and 11 is the same thing. So we don't really gain anything. So The other path we can take is going to be A to C, which is a 5, then go down to G, which is a 12, then go up to the E, that's going to be 14, which is greater than 11, so we don't want to do that. We can try another path, like, go A down to D, go up to the C, which is a 8, and then come down to the G, which is a 15 already, so that is not going to make any sense, right? So we try all the other paths, it's not going to make any sense. So, uh, you know, I'm just showing you, why, this is going to be the choice. Now, if you have the last one over here, it means you're pretty much done. I mean, because all the other, vertices that I marked boxes over here, that means you are finished with the vertex, and there's no way that you can, go to that vertex and find the better path. So I'm just going to write down 11C here. Okay, bring down the 11C. And we don't have any, better path over here. So this is the table that we came up with using Dijkstra's algorithm. So I'm just going to talk to you about a couple of things over here. So let's look at the this guy over here. I just explained it. Okay, so give me a second. This is what I'm talking about here, 11C here. Okay. So from F to E is 5 units. Since we are at 8C, okay, it indicates that we have 8 units at F. Okay, so what we're saying here is that we are at F, okay, but 8 units are coming from through the vertex C. Okay, so since 8 plus 5, right, 8 plus 5 equals to 13 units, right? And that's what we have up here. Because if you look at the, from F, as we mentioned over here, if you are at F, okay, and the coming from C, starting at A, at the you are sitting F here with the 8 units, right? And then from F to E, you add another 5 units, you're going to end up with 13 units. But 13 units is going to be greater than 11 units above. That's why we are not going to take that path, but we are going to take the path from A to C and C to E, which is the 11 units. Okay, so that's what the 11C was. Now next one is going to be the one of a 9F. So that one's this guy here. Let me just put the star mark over here. Oh, I used the blue. Okay. So that at 9F from F to G. Okay, so if you look at the FG, F and G is 1 unit. Okay. Now remember that the we are at 8C. So we are sitting on 8C over here, 5, 3, right? And we have 8 unit and F coming from C, right? And we have 8 plus 1. If you want to go through G, you got 8 plus 1, 5 plus 3 plus 1, that's 8. And the then compare that to the coming from C and the D. So in other words, that instead of coming from A, C, C, F, G, the 12C that you're looking at right here is going to be coming from A to D, right? and then the going up to C, which is A to D, D to C, then C to F, and F to G, and that's going to be a 12. And 9 is going to be much more smaller than, and that's why we are selecting the 9 rather than 12. So once you're finished, okay, now remember the last one is going to be, this is going to be your vertex. And we didn't find out any other ways to go to that. All right, so what we have here is that, okay, so we need to look at the red boxes, okay? So I'm just going to tell you 9F, okay? So we are on the left-hand side. So we are at G, and 9F means it's come from F, okay? So G here, okay, looking at G over here, then you are coming from 9F, okay? AC means if you look at the F, you got AC over here. It comes from C, and up to that point, it's going to be 8 units. And the 5A, it comes from A, and up to at that point, now you accumulated 5 units there. Okay. So the shortest path from A to G. Okay. So we are going to look at how we're going to do this. Okay. So it's, so from, you have to go backward. Okay, so let's just take a look. So we are at G over here. G is now, then I have to go to the F because it's telling me that I need to go to F here, subscript. Okay, so I'm going backward from here on the left-hand side. I'm coming from G, then I have to go to the F. Then F is, this is the column over here. The F column's telling me I need to go to 8. I mean the C. Okay, so then I go to the C. Okay. Then C column tells me that I need to go to A. Okay. So the shortest, it's the shortest or fastest path. Maybe I should rewrite this here. So where are we? Oh, backward. Okay. So here I'm going to erase this. The fastest term, path, I mean. So the fastest path from A to G is that, as I mentioned, from the G is telling me that I need to go to F, okay, because the subscript is the one that's telling you where to go. Okay, so G column tells me I need to go to F. So I go to the F. Then the F column telling me that I need to go to the C column. So I go to the C column, and the C column tells me that I need to go to the A, and A is going to be just the starting point. Now, whatever that number that I just hoop through here is going to be the the weight or units that accumulates until all the way to the end. So we're just going to look at it. So right now, from the boxes, the red box and then the column indicates that I should go A, C, F, and G. So now if you look at the A, C, F, and G, we have, several, I mean, there are other paths besides A, C, F, and G, right? I mean, you could go like A, B, D, F, G. I mean, the A, C, F, G is not unique path, okay? There are some other paths that you can take, but that's not going to be the fastest, okay? So, if you look at the total weights that we are going through the ACFG, it's going to be the 9 units, right? Because A to C is going to be 5. Then we go from C to F, that's the 3 units. And then from F to G, we get 9 units. And that's exactly what you see here at 9. Okay? So you didn't even have to calculate this. You just have to look at what the red box is indicating. Okay, so that's going to be the 9F. Okay. And I actually calculated down here 5, 3 plus 1 equals to 9 units. Okay. So this is going to be what we call the Dijkstra's algorithm. Now there are some other ways you can do this, not using this table, but you actually do the same kind of things on the directly onto the graph. But it takes sometimes it's very confusing. If you do it this way, at the end, if you want to go from like A to F, you know exactly how many units that you're going to take from starting to the end point. You're just going to have to look at the total weight in the red box in this case. And then you're just going to look at the path is going to be subscript. You're just going to have to go backward. Then you're going to end up with the A there. So this is something that I want you to try before you come to class Friday, and we will do a couple of more examples on the class. But before you come to the class, I want you to try this graph. I want you to set up the table, and then I want you to fill in the table. Okay, and we want to find the fastest path from A to H. Okay, so I should maybe write down here. Okay, so I would say find. Okay, fastest path from A to H. Okay, so that's H over there. Okay. So I like to see you guys set up a table like I have. Okay, then go through the each path. Okay, and if you can color them, that would be great. And so that you can see what goes where. Okay, so now in this exercise, if I want to find out the fastest path from A to F, then there I know that it takes about 8 units. Okay, then it's going to be F obviously at the end. Then I'm going backward. F C A. Okay, and that would be the fastest path to get to the F. Okay, so I want you to try this. If once you understand this thing, it's not going to be that difficult. Okay, you just follow the evaluate each path as you go to the next one. All right. I'll have the BFS and the DFS. Couple of examples so you guys know exactly what we're supposed to do there. I will ask you to show me the process of NQ, DQ, and push and pop for the BFS and DFS. So you guys are going to have to learn how to do that. All right. Okay. Thanks, and I'll see you Friday, if not before. We'll talk more about the Dijkstra's algorithm on Friday. Okay. All right. Thank you. I'll see you later. Okay, bye-bye.